Hello everyone. So now that we have the functions that we need to compute the distance and the bearing, so we have our get distance and get bearing, and we also created a get DMS to convert the angle in radians to a degrees, minutes, seconds format. All we need to do next is to loop through our points list and then compute the distance and bearing between each pair of points. So from point 1 to 2, 2 to 3, until you get to 5 to 6, and then 6 to 1, right? Because we need to go back to 1. Okay. So first off, let's create a list that will hold our final output. Okay. And then we will loop through our points list. Okay, so this is our points list, remember? So this is it. This is it. So we already have our data there. And then for this particular loop, we need to take note of our current index and our previous index. Okay, so I'm just gonna write it out first. Current index. So for the points list, the points is a list, right? And it has a function that you can use, index of element. So basically what it will give us is the index of the element that we are currently manipulating. So for example, so for the first loop, okay, so for the first loop, so for example, if we have the point 1, right? So when we go into the loop, so it will, the value of the current index will be 0 because that is our first element there, right? So that's basically it. This will give us the index of what element are we working on right now in the loop, in the current state of the loop. And then we also need to take note of the previous index because we will be computing the distance and bearing between 2 points, right? So we need the current point and the previous point, or the current point or the next point. So in this particular case, I just chose the previous point. Okay, so points dot index and then element minus 1. Okay, so for example, if we are already in index 1, right, that means that is the second element. So the current index will be 1 and the previous index will be 0. Okay, so you will get an idea of why we're doing this as we go along. Okay, so now let us create some if statements. So if the current index is equal to 0, okay, remember this is a logical operator here, equal to 0. If the current index is equal to 0, that means we are in our first element pa. So colon, I will continue. So it will continue through the loop. It will no longer go through all of the code after the continue statement because we only have 1 point. We don't have yet 2 points, so we can't compute distance and bearing like that. Okay. So I'll just continue the loop. So it will go to the second index. So else, if it's not the first index, so we can now compute the distance, right? So distance is equal to get distance. We are going to use our function that we created and points. So take note, this is our list, right? This is the same thing as this one. Then we are now going to use the indices that we created. So points, previous index, and then element. Okay. Okay, so why is this the case? Why are we doing this? Because if we recall, get distance, the starting point and the end point, right? So that is the sequence of our parameters. So in here, we must start with the previous index. So in this case, this is index 0. So the first element you will get the first element, and the element here will be our second element in the points list with index of 1. Okay, so we will compute the distance between those 2 points. And then we will also get the bearing. So we will use our function get bearing and then points, and then same thing, so previous index and then element. Okay, so that's basically it. We have our distance and bearing. And now we will take note of the line. So we will create a variable named line. So this will be the start of our final output, line, distance, and bearing, right? So points, so previous index, and then I will put another square brackets 0 so that we can access the first element in each element of the points. I'm sorry that can be a bit confusing, so I'm just going to write it out here. So remember that this is the structure of our points list. So we have 1, and then our northings like that sample, and then also have it. So if for example, so line previous index, so let's say this is our previous index, so this is the line, right? So this is, I mean, this is the corner 1, right? That's why, so this is index, this has an index of 0, and this is index of 1, and then this has index of 2. Okay, so that's why we entered 0 here. Okay, and then plus you will use a dash, so, and then plus, so we're just concatenating element 0. Okay, so this is the same thing. This is just the current element, and this is the previous, right? The previous element. Okay, and then we have distance bearing. So we are now going to append this new calculated data onto our distance bearing list. Okay, so we have our line. We have line, and then plus. So there's no need to cast this line into a string, no, because there are already strings. They're already strings. The indices are already strings, so there's no need to cast it into strings. So plus. So let's put a comma in between so that we can easily convert it into a comma separated value if you want. And then str, and then we have distance, right? The calculated distance, and then we put another comma, and then we add str. Let's just bearing. Okay, convert it into a string, and then of course we need to add a backward slash n, because this is like indicating a new line. If you recall in the basics of Python, this is a new line. Okay, this will um, uh, this will format our text file conveniently. Okay, so that's basically it, no? So we have, so this is the data that we need to input or output in our text file. So now we need to create another if statement, because once we reach the last, let's say for example, we started at 1 to 2, and then let's say for example our last point is 6, and then so if the loop is already in 6, and then the previous point of that is 5 and 6, so it will compute the distance and bearing of 5 and 6. But since 6 is already the end, the loop will end there. So we need to compute the distance and bearing of 6 to 1 if you are already in the last element of our points list. Okay, so if current index is equal to the length. So if you recall, this function right here, length, will get the number of elements in our list. So points list. So let's say we have so what do you call this? Let's say we have a list of, let's just write it out here. So we have a sample list. Sample list is equal to 1, 2, 3, 4, 5. Okay. So if you print length of sample list, then you will get a value of 5, right? Okay, so that's it. But so let's just write it here, points, and then we need to subtract 1 from that because the final index is not 5 but 4, right? Because we start in indices, we start with 0. Okay, so now you get it. If current index is equal to length of points minus 1. Okay, so we are going to compute the distance and bearing again. So distance is equal to get distance, and then the element. So we will start with the final element, and then the next is the point in points, and then the first element. Okay, so same thing with the bearing. Get bearing, and then the element, and then the points 0. Okay, so now we have from the final element to the first element, and then line is basically element 0, and then plus, we have here our dash, and then plus points 0, and then 0. Okay, so now we are going to append again. So basically the same command, so I just copied it. So that's basically it, guys. So it will now give us a distance and bearing with the data that we want. So let's try it if it actually works. So for element in distance bearing, let's print the element. Let's see if we got the results that we want. Okay, so here we have our data right here. Okay, so this is exactly what we want. So we have line 1 to 2, our distance and our bearing, and then so on and so forth, no? 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 1. So for that last bit of code, this is what we were aiming for. Okay, this 6 to 1. Okay, so that's basically it. So our final goal now is to write it out to a text file. Okay, so we are now going to use the open command again. Same thing that we used in the first part of this series. And then we are going to copy the same location. No? We're going to output in the same folder. But we are going to write W here. W, and then this will be, let's see, result.txt. Okay, result.txt, then as output. Okay, and then for line, let's just do a for loop now in distance bearing, and then output dot write. Okay, so we are going to write each let's just use element because we are used to the word element, but you can use any other word, you know. So element, for element in distance bearing, output dot write that element. So every single element in distance bearing will be written in our result.txt. So let us now run this code and let's see if we actually get a new txt file displaying our results. So we run it. Let's see. So we have no errors. We have no errors here. So let's go to our folders. Okay, so we have here our result.txt. So let's see. Okay, so there we have it, guys. So isn't that just amazing? So we now have our results, our line, distance, and bearing. Okay, so that's really cool. Now, in the next session next Thursday, we will use the second approach. We will create a class, and then we will use the objects of that class to compute this same result, and then we will also use the graphing function using a library. Okay, so thank you for watching this series of videos. I hope you learned something new and have fun coding.